Well, hello 4C, and welcome to applying the primary trig ratios. Look at our goal today. I can use SOHCAHTOA to find missing measurements in word problems involving right triangles. Oh, look at that. I capitalized it this time. That must mean it's really important. You cannot use the primary trig ratios unless you have a right angle in the triangle. Fortunately, right angles are all over this world because vertical and horizontal meet each other at a right angle. So there's lots of times that we can use the trig ratios to find side lengths and measurements that are not directly measurable, but we may need to know. So first of all, we need to figure out what definitions are, and I'm going to show you these. If you ever see the words angle of elevation, and sometimes you'll hear it not just elevation, but you might hear it called inclination. So elevation or inclination. More often than not, it'll be elevation. And depression, sometimes called declination. But again, you'll hear depression more often. We have to figure out what it means by angle of elevation and depression. So here we are. I've got this situation. We got the CN Tower, and we've got this little birdie looking down at this girl, and this little girl looking up at the little birdie, and this little birdie is right at the very tip top of the CN Tower. And so this girl is looking up at the birdie, and the birdie's looking down at the girl. Well, they're both actually looking at the same angle, because the little birdie, normally he would be looking straight forward. But he has to tilt his eyes down to look at the little girl. And this angle that he has to tilt his eyes down to actually see the little girl is called the angle of depression. So this in here is the angle of depression. Now, depression is always looking down. Remember, if you're depressed, you're feeling down, you're feeling kind of lonely and depressed and down. So angle of depression means down. Now, look at this little tyke down here. She's looking up at that birdie. She's wondering why that bird is sitting at the top of the CN Tower. Now, again, if she was just walking along, she'd be looking straight forward. But then she looks up and sees the little bird. Now, that angle that she has to look up, that she either tilts her head or she tilts her eyes, that is the angle of elevation. And I just realized that I've actually typed these things in here, that I can put those, that looks a little bit neater. I'm going to rub out this nasty handwriting thing here. So we have angle of depression, angle of elevation. So going up and going down. Now the important thing is here that at that bird, the angle of depression is not this in here, because this is between the vertical. This is not the way the bird's going to tilt his head from normal. So we want to think about what the normal line of sight is, and then what the line of sight is to get to the object that we're looking at. So I'm going to delete that. It's never between a vertical and a horizontal, or sorry, and a diagonal. This line here, where the bird is looking at the girl and the girl's, this is called the line of sight. The line of sight. And angles of depression and angles of elevation are always between a horizontal line. Now, you know what horizontal means. It follows the horizon. A horizontal line in the line of sight. So they're always either going down or going up. They are never going out. Okay? So keep that in mind. That's one of the biggest mistakes that we see. So, and that's what it says down here. Angles of depression always look down on something, where angles of elevation look up. An angle of elevation or depression is always made up of a diagonal arm and a horizontal arm, never vertical. So let's have a look at these things. 5 steps of solving trig word problems. Recreate the situation with objects if necessary. If you have to actually build a little model of the CN Tower with a little girl looking up at it, you're more than welcome to. Draw a diagram if one is not given. Label the triangle with sides OA and H. Now this is actually looking a whole lot like all of the other ones. This is the only part that's different from the things that we solved already. We have to recreate the situation and think about the diagram. Once we have the diagram, then it's the same as the rest of it. So let's think about these situations here. Here's the first one. Sally stood 75 meters from the base of the CN Tower and looked up to the tip top. Okay, so I'm going to just draw, remember this is a rough diagram. I get a better diagram of the CN Tower over there, but this will do. It says Sally is standing 75 meters from the base of the CN Tower. So that means that this in here is 75 meters. Okay, now notice I got that just from the first sentence. Sally stood 75 meters from the base of the CN Tower. Now she's going to look up. So from her eyes, she looks up to the very tip top of the CN Tower. Now this is called the line of sight. LOS. Line of sight. She measured the angle of elevation. Now remember, her eyes is where she's measuring it from. So we have to have a vertical line coming out from her eyes. She would be looking straight forward, and then she tips her head up. And she measured that to be 82 degrees. How did she measure that to be 82 degrees? She probably had a little gravity protractor. Something that looks like this with a little string and a weight on it. And when you tip it up, the weight stays going down and it tells you what the angle that you tipped it at. She probably had one of those. Okay. So she measured it to be 82 degrees. If Sally's eyes from where she took the measurement are about 1.5 meters above the ground, so her eyes, so this in here is 1.5 meters. How tall is the CN Tower? So here's the height of the CN Tower. Now, of course, when we find it, we're finding that the height part of this triangle, and we still have this 1.5 meters on the bottom to add in after we're done, because that's part of the height too. So let's figure this out. Our steps up here, you should have them sitting in front of you. It says label the triangle with sides O, A, and H. So remember, it didn't say circle the angle, but I'm going to circle the angle. I'm going to go with red this time. I'm going to circle the angle we have. And I'm going to label the sides with O. So O is opposite this. H is this. And A is this down here. Okay. And now we have to set up the ratios. So here's our angle, 82 degrees. And we want to use, well, H is useless to us, because there's no side length given there, and we don't care. We're not attaching a string to Sally's head in the top of the CN Tower. That might be fun. We want to use opposite and adjacent. So opposite and adjacent, if you remember, opposite and adjacent is tan. So I'm going to put tan here. Opposite over adjacent is H. Little h, that's the height, over, looks like 75 meters. And now, tan of 82, remember we can get that. I'm going to clear this. I'm going to make sure I don't have that shift up there so that I have just sine, cos, and tan, because we're not finding an angle. The only time you need that -1 is if you're finding an angle. So 82, tan. Now again, depending on your calculator, you might have to hit tan and then 82. So 7.1154. 7.1154 equals h over 75. Now we could use cross multiplying. If you want to use cross multiplying, you need to do this and then go h times 1 and that times that. I prefer not to do cross multiplying in this situation when I've got the h on top. It's much easier to say I'm going to do it by isolation. So if I do it by isolation, I'm going to multiply this side by 75 to get rid of that 75, and then I have to multiply this side by 75. So that's going to give me the h. Whoops, that's not what I wanted. That's going to give me the h by itself. And then on this side, I have to multiply this number, 7.1154, by 75. Now again, luckily that's 7.1154. I didn't remove that from the calculator, so all I have to do is go times 75 equals, and that's 533.65. So 533 point, I'm going to go 7.7 meters. Now of course we have to add in this 1.5 meters too. So if I add in that 1.5 meters, we're going to go 533.7 plus 1.5 plus 1.5, 535, basically. Now, that's not quite the height of the CN tower, but when we're rounding all these angles and stuff, we're not going to get anywhere near exact measurements. We've got two more examples. An airplane is flying at an altitude of 1,200 feet. What does altitude mean? Altitude means how far it is above ground. So I'm going to draw the ground. Look at the grass. Ooh, it needs cut. Okay, now I'm going to draw an airplane up in the sky. Should have been an art teacher. Let's put a little propeller. That looks nothing like an airplane. Oh well. 1,200 feet is how high it is up there. So 1,200 feet. So let's actually draw this as a triangle. I'm going to put this down here. 1,200 feet. Now remember, vertical meets horizontal at a 90-degree angle. The pilot spots an airport at an angle of depression of 15 degrees. Now remember, the pilot, when he's flying the plane, he's looking straight ahead most of the time, or at least I hope he is. Looking straight ahead. And he has to look down to spot an airport. Let's draw our airport. Here's our airport. Looks a whole lot like a box. So he has to look down to spot the airport. And when he looks down, that's the angle he measures. He does not measure this one. No siree, Bob, and neither are you. We're going to measure this one here, which he told us is 15 degrees. What is the distance he must travel in order to be directly above this airport? Well, if he wants to be above the airport, which distance is he going to travel? Is he going to travel this distance? Is he going to travel this distance? Is he going to travel this distance? Oh, I hear you screaming. He's going to fly straight. He's going to fly straight. So it's this distance here. This is what we're trying to find. Let's put a D there. Now, of course, this altitude is going to stay the same. He's not going up or down. So this is still 1,200 feet once he gets above the airport. And this is 15. So let's do our little magic. Circle the angle we're going to use. Label all our sides. Here's the hypotenuse. Go across the triangle. That's our opposite side, and this is our adjacent. What do we need to use? Let me get my highlighter. I like using this highlighter. I'm going to use blue highlighter this time. We need to use the distance, because that's what I'm trying to find. And we need to use something with a number on it. So let's set this up. This is side O and A. O and A is TOA. TOA, ladies and gentlemen. So we're going to use 15 degrees. And since TOA is what we're using, we're going to put tan. Tan is OA, opposite over adjacent. So I need 1,200 over D. Now remember, tan of 15 is just a number. Tan of 15. 15 tan. 0.2679. 0.2679 equals 1,200 over D. If you want to solve by isolation, and I'm going to move this next question down a bit. Hopefully you left some room on your page. If you want to solve by isolation, you can. I'm going to just quickly say we could put this over 1, and then we can flip both of these over so that that D's on top, so that I go D over 1,200. And if I've got D over 1,200, then this has to be 1 over 2679.2679. And now to get D by itself, we multiply by the denominator. Multiply by 1,200 on both sides. I know a lot of you do like the isolation, and then those will cancel each other out. So what we have left with here is D. And then over here, it's 1,200 times 1 divided by that thing in the bottom. So 1,200 times 1, which is just 1,200. Don't type that into your calculator. 1,200 times 1, and then we divide by 0.2679. So 4479.28. 4479.28, and that is measured in feet, ladies and gentlemen, because the original measurement was given in feet. Ooh, I've just suddenly got a whole lot more stuff there. There we go. It's gone. All right, down here. Example 3. Mrs. Broadhagen is fixing the soffit on her house. In case you don't know, the soffit is the stuff up at the eave on your house. There's soffit and there's fascia, and it's all up there, but it's on the eave of the house. So she's got to get up high if she's going to get up to the eave of her house. So let's draw Mrs. Broadhagen's house. Here's our house. And Mrs. Broadhagen has to get up here. She has a 20-foot ladder. And she places it 4 feet out from the foundation of her house. So this ladder is 20 feet long. And she places it 4 feet out. What is the angle of elevation between the ground and the ladder? So, do I want this angle in here? No, you're right, I don't want that angle. That's between the house and the ladder. This wants it between the ground and the ladder. So it's this angle down here I want. I'm going to call that angle in there theta. Here's our right angle. And let's go through this motion again. I'm going to do the circling. There's the red. I'm going to circle theta. And then this is opposite. This is the hypotenuse over here, and this is the adjacent. I don't know anything about opposite, and I'm not asked to find anything about opposite. I want to use that theta, so I'm going to write down theta. The two sides, we're finding an angle this time, so the two sides that I have numbers for are A and H. So which is that? So, nope, not so. Oh, there's my A and H. So I want to use cos, and that's A over H, so 4 over 20. Now remember, we're finding an angle. Anytime you're finding an angle, you've got to use that cos -1 or sine -1 or tan -1. So here we're going to go 4 divided by 20 is 0.2. And now to figure out what theta is, I have to do cos -1 of that 0.2. And bring up the calculator. 0.2 is already on there. Neat. Now I have to do cos -1, so I got to press shift first. Cos -1, 78.5. Now, since these are all word problems, we should end them with a therefore statement. So we can say, therefore, the angle is 78.5. And the same with this one up here, we should have had a therefore statement there too, and say, therefore, it will be above the airport in another 4,479 feet. And that concludes this video.